Hello and welcome to second of 3 lessons about slope-intercept form of the equation of a line. In the last one we learned how to use slope-intercept form of the equation of a line, and just to remind you, slope-intercept form of the equation of a line looks like this. It's where you have the y by itself, you isolate the y, and then you have some number m is a number, times x, which is your input variable, plus b, which is your y-intercept. Slope-intercept form looks like this. That number in front of the x will always give you the slope. The number at the end will give you the y-intercept. Now, if you have a number subtracted at the end, that's the same as adding a negative. So if I had y equals negative 4x minus 5, my slope would be the negative 4. Sorry, m equals negative 4. And that's the same as negative 4x plus a negative 5. So the y-intercept is also negative. It's a negative 5. So we talked about that in the last lesson. That's just a little bit of review there. So once I have my line in the form where y is isolated, it is pretty easy to graph it. Remember what the y-intercept means. The y-intercept means, I'm just going to write a little xy axis up there. The y-intercept gives you where you have a point on the y-axis. A line will only have at most one point on the y-axis, and this b, this number at the end, tells you at what y value that occurs. And then the slope tells you rise over run, tells you how far up is the rise and how far over. It gives you a way to find another point. That's what we're going to see. So graphing the y-intercept is easy right away. It's the point 0b. Remember, every point on the y-axis has an x-coordinate of 0. And to get the second point, we use the slope. And then we draw a line. It says use a straight edge or the edge of an index card. I don't have that available for my screen, but you would draw the line. So let's move on and see an example of this. So this is nice. My line is already in slope-intercept form, and that will make things easier. Y is already isolated. The equation y equals 2x plus 3 is in this form. So I know the slope, and I know the y-intercept. I start with the y-intercept. So I know m equals 2 and b equals 3. And they've written that out in words here. So I can use 3 steps to graph this equation. The first step will be I plot the point. That's the y-intercept. If you look back at our last slide, the y-intercept is 3. That means the y-intercept is the point 0, 3. It's on the y-axis, so the x-coordinate is 0. So I graph that point 0, 3 right here. Now, after I've graphed that point, I need to find a second point. In order to graph a line, you need to find a second point. You could find a second point by picking a different value of x and putting it into your equation. You had the equation y equals 2x plus 3. You could pick a different value for x and say, if x equals 1, y equals 2 times 1 plus 3, which would give you y equals 5, and you'd have the point 1, 5. You could do it that way. As a matter of fact, that's the way as a student I preferred to do it. 1, 2, 3, 4, 5. I have the point 1, 5 right there. But if you are more visually able than I was as a student, if you like to see things better, I didn't work as well from seeing things. The numbers made more sense to me. You can use the slope. You were told the slope is 2. 2 is the same as 2 over 1, and you have to remember slope is rise over run. And we're going to see this again on the next slide, but for now let me show you. Here's your rise. You went up this far. That's your 2, so you count up 1, 2, up. So you start at the 0, 3, and go up 1, 2, and then you go, the run is 1. So you count up 2 for the rise, and then to the right 1 for the run, because they're both positive. And what you see is you get a second point there, and now you could draw your line. Let's take a look at the next slide to take another look at that. So here we are. We graph our point 0, 3. Then we look at our slope. and write it as a rise over a run. The slope originally was just a 2, but that's 2 over 1, so the rise is 2 and the run is 1. That means every time you go up 2, you go to the right 1. So we start at 0, 3, and we go up 2. You can see that's what it shows you in blue there. You go up 2, and then you move over 1. Now, if you add 2 to the y, so the rise, remember the rise is the change in y. And in math, when we mean change in, we use this triangle, means delta y. So I take my old y plus the rise to get a new y. So I have my old y was a 3, the rise was a 2, my new y is a 5. The run is the change in x. Let me write that over here. Run equals change in x. I take my old x plus the run, and that gives me my new x for the second point. So my old x was a 0, the run was a 1, I get a second point. X is 1, y is 5, so I get the point 1, 5 to graph. You could do that visually by going up 2 and then to the right 1. Or you could just put x equals 1 into the equation y equals 2x plus 3. But once you have 2 points, you have the graph of the entire line. The pattern holds true for every value of x, so you connect the points and then you draw arrows at the end. So here's a second example, this time of y equals 3x minus 2. The y-intercept is negative 2, so we plot the point 0, negative 2. That's over here. The slope is 3 over 1, so from the point 0, negative 2, I go up 3, 1, 2, 3, and over 1, and that gets me to the point 1, 1. Okay, let's try this again. So, x is 0. 0 plus the run will give me my new x. So my new x is a 1 because the run is 1. Y is a negative 2. Negative 2 plus a 3, this is the rise. You add the rise to y, gives me a 1, so I get the point 1, 1. It's probably much easier for you to see it by starting at the y-intercept and counting up 1, 2, 3, and then over 1 and putting another point, and then drawing a line between them. Note the arrows on the end of the lines. All right, here's another one. Now this time, I don't have an integer for my coefficient of x except for my slope. I have 3/5. Sometimes students find this easier. The y-intercept is 1. That's at the end of the line, at the end of the equation. You have y equals 3/5 x plus 1. So you graph the point 0, 1. And then you go up 1, 2, 3. So your new y will be 4. 1 plus 3 is 4. And then over 5. And your new x is 5. So the rise is 3. Run is 5. The other thing you could do is you could plug a point. So finding the point 0, 1, graphing that is easy. You just need a second point to graph. If you have y equals 3/5 x plus 1 and you don't like this looking at the graph and counting, see how you have a 5 in the bottom of that slope? Let x equals 5. Let x equal 5 and substitute it in to find y when x is 5. And whenever you multiply a fraction times its denominator, you're left with just the numerator. So you get y equals 3 plus 1, which is 4. So your new point when x is 5, y is 4, is 5, 4. So if you don't like it doing this graphical method, you may do it using this algebraic and numerical method. You use the straight edge to draw the line, do the best you can, and put 2 arrows in. In MyMathLab, you pick a tool called the line tool, and you give it 2 points, and it draws the line for you. So you want to be able to do that. Remember, you just need 2 points. There are multiple ways to get 2 points. One of them is by this counting the rise and the run. Another one is what we did in earlier lessons. We just pick a different number for x. The y-intercept is when x is 0. So if you pick a different number for x and calculate y, you'll get another point. When your slope is a fraction, a convenient point to pick is the denominator of the fraction, because then you're left with an integer for that term. Okay, let's take a look at the next example. Oh, okay. So in the next part, we're going to figure out how can we graph using slope and y-intercept when we're given standard form. So that's all for this lesson 2. In lesson 3, we'll move on to the other form of the equation.